Hello and welcome back to CPP Under the Microscope. My name is Sam and today we're going to put a common C++ pattern under the microscope, returning objects from functions. We all know that returning by value can sometimes cause copies, but modern C++ has optimizations like RVO or return value optimization that can eliminate those copies. But how does it actually work? What does it happen? And what happens when you try to help the compiler with stdmove? We'll answer these questions by diving into the assembly generated by GCC and Quang using the Compiler Explorer, also known as Codeboat. Let's start with the basics. Let's start with a small object like an int. If we compile this with optimizations like O2, we get something like this. The multiplication happens in EDI, the first argument, and then the result is moved to EAX, the register used to return integer values. This is simple, fast, no memory involved. Small objects up to 16 bytes, depending on the platform, are typically returned directly in registers. But what about bigger objects? Now let's look at a large object. Now let's reduce the optimization level to 01. Check the assembly. The assembly will look something like this for makeBig function. Even though we didn't declare pointer parameter, the compiler adds a hidden one, this RDI. This pointer points to the memory where the returned big object should be constructed. The function writes the data directly into the cover's memory, avoiding any copy or move. Main function, and we need to make this O0 to be able to see it. Here is RDI, we set it here, and this is the amount of bytes we need for the big object. So here is how it's set, and then we call begint. RDI is used here. That's the location where the object should be constructed. Our function here will write in place where that RDI is pointing. Key point: large objects are returned via a hidden pointer, so the compiler can build them in place. This is essentially RVO at the ABI level, independent of whatever you explicitly return a temporary or local or a named local. Even though with this hidden pointer, the compiler can still perform an RVO, which is named return value optimization, or await moves if you return a local variable. So the zero copy optimization still applies inside the function. This version makes it clear small objects are returned via registers, fast, no memory copy. Large objects, hidden pointer constructed in cover memory avoids copies. NRVO and RVO optimization still matter for how the object is returned inside the function, even with this ABI mechanism. Let's look at a returning a temporary object. Here, the big object is a temporary object, a PR value. Modern C++ compilers, C++17 or higher, guarantee copy elision. The object is constructed directly in the cover's memory, as I saw in the previous example. The RDI register here, and we can see it in the main that it has been set here. Also, no copy or move constructor is called at all, even if you define them, as we have did. The compiler can skip them completely. We can see it called the first constructor here. And in the assembly, we can see it as well. Only one constructor code, this one here, which is this one over here. And that's with O0. If, for example, change it to O2, again, the same behavior and even much more optimized. But we can see again the RDI. What if we return a named local variable that's called nRVO? The compiler may avoid the copy move by constructing local directly in the return slot. nRVO is not guaranteed, though most compilers do it for simple functions. If nRVO doesn't apply, for example, multiple return parts or the local is copied or moved when returned, there are rules about the nRVO, but in general, modern compilers can and will avoid and just create the object in place. But it depends. It's pretty much the same example. As you can see, RDI is here, and that's with O2. Let's make it O0. Basically the same thing. Here we have the call to the constructor, which we see here. The main, here is RDI. Here is the code to make big nRVO. And again, RDI register. We call the constructor, and it's basically the same thing. A common mistake is forcing a move on a local variable. Let's see the example. As you can see, even the compiler, well, I have added flags for the warnings, but we can see even the compiler warns us about, and here's what it says. Moving a local object in a return statement prevents copy elision. Let's check the assembly. Here is it. Make big with move. Again, we can see the RDI register, but something to note. We can see this constructor code, which is this one here. And then we can see the move constructor. Again, we can see it here. And we can also see that we have additional bytes set aside for that object. Using stdmove prevents nRVO because the compiler now treats the local as an X value. If a move constructor exists, it's called. Otherwise, a copy occurs. Even if the move is cheap, you lose the zero cost optimization that nRVO would provide. And the rule of thumb is don't stdmove a local in a return statement. As you can see, even the compiler tells us not to do that. The compiler already knows it can avoid or remove it efficiently. Forcing it usually just adds an extra operation. Let's recap what we've learned about returning objects in C++. Small objects like int, double, or struct that's less than 16 bytes are returned directly in registers. This is extremely fast. No memory copy is needed. Large objects are returned via a hidden pointer provided by the caller. The function constructs the objects directly in the caller's memory. This avoids extra copies and is part of the ABI. That's not a compiler trick. RVO, return value optimization, and nRVO, name return value optimization, are compiler optimizations that eliminate copy move operations by constructing the object directly in the caller's storage. These optimizations are most reliable when returning PR value, temporary object, guaranteed copy elision in C++ 17 or higher. A simple named local may apply nRVO that's compiler dependent. Using stdmove on a local variable when returning it usually backfires. It inhibits nRVO and forces a move or copy, adding a unnecessary operation. Bottom line, the cost of returning large objects is usually just the construction cost. Modern compilers are smart. Trust them. Write clear idiomatic code and let RVO and RVO to do the heavy lifting. If you enjoyed this deep dive, hit like and subscribe. In the next episode, we'll explore another C++ feature under the microscope. Thanks for watching.